Hey everyone, so this is the second video about proofs. The first one, part one, is different. We went over some more stuff there. So if you're tuning in right now, I would say go watch that first video first. So all I'm doing here is I'm finishing up because we ran out of time for a second example. So here is our theorem. As you can see, there are no premises here. We start off with that turnstile, which means that this is a theorem. This sentence is derivable just from itself, just by pushing around the different parts of these sentences using this sentence, using the rules that we have at our disposal, we can prove that this is a theorem. And so here's what we're going to do. We are going to take a look at this. Okay, so this is just like having a conclusion, but no premises, right? So in the same way we look at the conclusion of arguments that we want to provide a proof for, we're going to look at the conclusion or the theorem here, the statement, to see how we should strategize here. When I look at that, the thing that calls out to me first is that the main operator is a conditional. All right, and so what that means is for my proofs, I'm going to need to use one of my hypothetical rules because I don't have any other information to get me started. So those hypothetical rules that we talked about in the last video, negation introduction and conditional introduction, are incredibly important for theorems. We can't get off the ground without those. That's why they're part of our basic rules. We need them in order to prove any theorems. All right, so what I'm going to do is I'm going to start off by assuming the antecedent, right? This is a conditional, so I will do a conditional proof, otherwise known as a conditional introduction for our set of rules. So I'm going to assume the antecedent, A or B, then negation C, and I'm hoping that it leads me to this consequent there, okay? So I'm assuming the antecedent, and anytime you do a conditional proof, right, I'm going to put H and then I'll put for conditional introduction. Assume the antecedent, show that it leads to the consequent. Well, when we do that, we look at that consequent and we say, okay, how in the world am I going to get that? That antecedent actually doesn't have much information for me. And so when I look at that consequent, my goal now is to think, what's the best way to prove that consequent? And I know that the main operator here is a negation. And if the main operator is a negation, then typically negation introduction is going to be very helpful. So let's do a nested subproof here. So just like we did in the last one. So I'm going to assume the opposite of what I want to prove. That means if I want to prove this whole thing, right, now I'm going to prove the opposite, or I'm going to assume the opposite of it, meaning I'm going to assume C and A. So this is a hypothesis for negation introduction. Okay, so now we can actually get somewhere, right? So if I have C and A, what can I do, right? My goal is to come right now in this nested subproof because it's for a negation introduction. My goal is to get to some kind of contradiction. I want to come to some sort of absurdity so that I can reject this hypothesis, right? And I can say, that's not the case, right? That's my goal. So I have C, I have A, right? From this, meaning that I can, if I need to, I can just get C from that. From conjunction, let's do line 2, conjunction, elimination, and I can also get A from line 2, conjunction, elimination. Look, if you are stuck in a proof and you see a conjunction, try breaking it apart to see if that will help you, okay? You can try and figure out what you'll need from that. Okay, I have C if I need it, I have A if I need it. What's going to be most helpful to me? Well, I see that C, right? I have that and that, but I can't like directly pull that out, right? I have a not C right there and a C in line 3. So not C happens in line 1, but it's just the consequent. Line 3 gives me C. So what am I going to do? It would be nice if I could put those together because that looks like a contradiction right there. It looks like an absurdity, right? C and not C. I can't quite do that yet though. What I'll need to do first is I'm going to need to get that not C by using conditional elimination or modus ponens, right? So in order to do that, I need that antecedent, A or B. Well, I just have A so far, but if you're familiar with the basic rules, you'll know that you could just turn that A into an A or B. That is line 4. Disjunction introduction. That's that rule that seems like it should be illegal to use, right? It's too easy. You forget about it sometimes, right? Because it's so easy. All right, if I have A or B, then I can combine that. So that's line 5. I can combine that with line 1 using conditional elimination to give me not C. Well, now I can put C together with not C. That is lines 3 and 6, conjunction introduction. So I just said, or I just proved, that if I had C and A, it would lead me to this contradiction. It would lead me to somewhere absurd. And so what I can gather from that is that it's not the case that C and A can happen, right? That's crazy, because if it did, we would come against this contradiction or this absurdity. So lines 2 through 7 were used in a negation introduction to show me that I have on line 8 right now. And so now that I have that, what I've done is I have, right, just proven that I can get that consequent from this hypothetical move that I made, right, in that first move. If A or B, then not C, then I could get negation C and A, right? So I just showed that if I had A or B, then not C, and I'll put those all in parentheses because now that's my antecedent. I just proved this conditional, right? If I had all that, then I could get this whole thing. And I did that from lines 1 through 8. And that was a conditional introduction. All right, so I hope that you were able to follow along. I hope that that was helpful, and good luck on the exam. If you can do these, you will have no problem with the proofs on the exam. They are not harder than this, definitely, and most of them are quite a bit easier. So good luck.